So if you've ever used an array in Java, you know they can feel a little restrictive. I mean, what happens when you need your list of things to grow or shrink? Well, today we're going to master the perfect solution for that, the array list. We're going to start from the very beginning and build all the way up to the professional, best practice way of using it to write clean, safe, and really powerful code. Here's the roadmap for our journey today. First, we'll look at why arrays just don't cut it sometimes, which is what makes ArrayLists so necessary. Then, we'll zoom out and see where ArrayList fits into Java's big picture, the collection framework. After that, we'll get our hands dirty and create our first list. But we're going to quickly spot a pretty serious flaw. We'll fix that with a super important feature called generics. And then, we'll give our code one last power-up before we wrap it all up with the key takeaways. Okay, so let's dive in. To really appreciate why ArrayList is so great, you first have to understand the thing it was designed to improve upon, the basic, humble array. Now, arrays are fundamental in programming, don't get me wrong. They're fast, they're simple, but they have one huge weakness. And that weakness, that deal breaker, is their fixed size. When you create an array, you have to decide right then and there exactly how many items it can hold, forever. So imagine you make an array for, say, 10 students, but then an 11th student joins the class. What do? Well, with an array, you're pretty much out of luck. You can't just add another spot. And that inflexibility is a major problem for any app that needs to adapt.
And this is where ArrayList swoops in and saves the day. See, unlike an array list is dynamic. It can grow automatically when you add new things, and it can shrink when you take things away. It's this flexibility that makes it one of the most useful and popular tools in a Java programmer's toolkit.
Now, to really get what an array list is all about, we need to zoom out a little bit. It isn't just some standalone tool. It's actually a key part of a much bigger, much more powerful system in Java. And that system is called the collection framework. The best way to think about it is like a toolbox, a whole library of pre-built, super efficient tools for handling groups of objects. It gives us a consistent way to work with lists, sets, queues, you name it. This table kind of shows the family tree. Think of something called an interface, like collection or list, as a blueprint. It just defines the rules, what a thing should be able to do. A class, like our array list, is the actual thing built from that blueprint. So an array list is a list, and a list is a collection. This is a relationship is absolutely crucial, and we're about to see why. All right, that's enough theory for now. Let's get our hands dirty and actually write some code. We're going to create our very first array list, starting with the simplest way possible. So here it is. On the left side, we're declaring a variable called nums, and we're giving it the most general type possible, collection. On the right side, we use the new keyword to create the actual real-life ArrayList object. You can think of it like we've just grabbed an empty basket ready to be filled up. And adding things to it is a piece of cake. We just use the .add method. So here we add a 6, then a 5, then an 8. And here's something really cool about collections. You can just print the whole thing directly, and Java gives you this really clean, readable output. No need to write a messy loop just to see what's inside. But wait, this all looks great, right? Super simple. But, and this is a big but, there's a hidden danger lurking in this simple approach. It looks harmless, but it can cause our program to crash when we least expect it. Here's the problem. Right now, our collection is, well, a bit clueless. It doesn't know what kind of data it's supposed to be holding. We, the programmers, think it's for numbers, but what's to stop someone from accidentally throwing a piece of text in there? So, let's just do it. We add the integer 6, no problem. We add the integer 5, still fine. But then, we add the string 8. And you know what? Because our collection is so general, the Java compiler doesn't even blink. It just says, sure, whatever you say. And just like that, we've planted a ticking time bomb inside our code. And here's when it explodes. Later on, maybe deep inside your code, you try to do some math with every item in that list. It's chugging along just fine until it hits that string 8, and bam! Your program crashes with a ClassCastException. This is what we call a runtime error, and it's the worst kind because it happens when a real user is trying to use your application. Thankfully, the solution is beautifully simple. Look at the code on the right. See that little integer in angle brackets? That's called a generic. It's like we slapped a giant label on our basket that says integers only. Now, if we try to add a string, the compiler stops us right in our tracks. The bug is caught while we're coding, not months later. This is a massive win for writing safe, reliable code. So, simply put, generics are like a bodyguard for your collection. They enforce the rules at compile time, which prevents those dangerous runtime errors from ever happening. And here's the main takeaway from this section. You should always use generics with your collections. Seriously, every single time. It's non-negotiable.
Okay, so our code is safe now, which is awesome. We've hired the generics bodyguard, and our collection is protected. But can we make it even more powerful? You bet. Let's make one final adjustment to unlock the full potential of our array list.
Remember that family tree we talked about? Right now, we're using the most general blueprint, collection. And that blueprint guarantees that we can add things and remove things, but it makes zero promises about order or position. You can't ask it, hey, give me the item at index 2. It just doesn't know how to do that.
But what happens if we use the more specific list blueprint instead? Well, as you can see here, when we declare our variable as a list, we still get all the basic methods from collection, but we also unlock a bunch of new superpowers. The two most important ones are getIndex, which lets you grab an item by its position, and indexOf value, which lets you find out where a certain item is in the list.
And this line of code right here, this is it. This is the gold standard. This is how professional developers do it. We declare the variable using the list interface to get all those powerful methods. We use generics, the integer part, for that critical type safety, and then we create the concrete array list. This combo gives us maximum flexibility, power, and safety. Oh, and notice the empty double brackets on the right? That's a nice little shortcut in modern Java. The compiler is smart enough to figure out the type from the left side.
Whew, okay, we've covered a lot of ground. We started with the limitations of a simple array, moved to a basic array list, made it safe with generics, and then made it powerful by using the list interface. Let's boil all of that down into a final, simple checklist.
Here's everything you need to remember. 1. When you need a list that needs to grow or shrink, use an array list. 2. Always, and I mean always, use generics to make your code safe. 3. Always declare your variable as a list so you can get access to all those useful methods like get and indexOf. Just burn this final line into your memory. List of type name equals new array list of type. That is the way.
And with that, we're at the end. An array list is an absolute champion at accessing items by their index. It's incredibly fast at that. But here's a little food for thought. What if your program's main job wasn't fetching items, but was constantly adding and removing things from the middle of a massive list, maybe with millions of items? Is ArrayList still the best tool for the job? That's a great question for another time.